Hello, my name is Mike Clodfelter, and I'm a Renesas application engineer specializing in the Renesas RL78 low-power 16-bit MCU family. Here's our agenda. Today we'll show how RL78 microcomputers are optimum for implementing IoT, Internet of Things edge devices due to low current consumption resulting in long battery life, high performance instruction processing, reduced time to market with great coding tools, flexible scalability, and security and safety features. Then we'll talk about near sensor processing and why it's important for IoT edge applications. We'll cover RL78's extensive design tools and ecosystem. Finally, we'll highlight RL78 application examples called quick solutions. On the left-hand side, Renesas has analog and power products and system-on-chip ASIC products, and on the right-hand side, Renesas has a new concept MCU platform called Synergy that integrates certified software on top of the device, where Synergy is an ARM core platform from Renesas. In the middle, Renesas has the traditional type of MCU business using Renesas proprietary CPU cores and a very broad MCU portfolio spanning all the way from low-cost, low-power 16-bit RL78 controllers up to comprehensive 32-bit MCUs with more than 47,000 Drystone MIPS performance. The Renesas 16-bit RL78 MCU is implemented in Renesas MF3 130nm silicon process offering ultra-low power consumption of 0.25 microamps in standby stop mode. That is, stop mode with no clocks but RAM contents retained, while still attaining as low as 66 microamps per megahertz running no-op instructions and 144 microamps per megahertz average operation current in CPU run mode. The result is highly efficient power consumption and up to 44 Drystone MIPS performance at 32 MHz operation. RL78 offers much higher performance compared to any other 8 and 16-bit microcontrollers in the marketplace. The RL78 MCU families offer both consumer industrial and automotive grade devices. The RL78 family offers true low power. RL78 low power consumption is exhibited in two major ways: power consumption of the MCU itself and efficient energy control of the end application. Since the RL78 itself doesn't draw much power, less than 20 milliwatts typical at 32 MHz operation with plus 3 volt supply and all the peripherals enabled, it will easily meet the appliance industry standby power target of less than 100 milliwatts drawn from the AC line. Then the RL78 MCU power can be reduced to a much lower value when the appliance is in standby and still maintain monitoring control. For example, at 1 MHz operation, all RL78 MCU functions can still be enabled and consume less than 3 milliwatts typical. On the efficiency side, the RL78 CPU core can attain 44 Drystone MIPS peak. This active CPU current drain is rated at 144 microamps per megahertz while executing code out of flash memory. Some competitors advertise a low current drain like 150 microamps per megahertz, but it only applies when running out of RAM memory space, sharply limiting the available code size. It will inevitably revert to flash code space when some functions or interrupts are invoked. Then the current drain is typically 250 to 300 microamps per megahertz. Scalability of the RL78 is a very flexible feature with pin counts spanning from 10 to 128 pins, and memory sizes spanning from 1K bytes to 512K bytes. The scalability includes a common set of CPU core, system features, and peripherals where ADC serial ports and timer peripheral operation is identical in all pin counts ranging from 10 pins to 128 pins. For system cost reduction, RL78 high integration and advanced peripherals reduce system costs by eliminating external components. A high-speed on-chip system oscillator, or OCO, with plus or minus 1% frequency accuracy is rated over the full voltage from 1.6 volts to 5.5 volts, with full temp range from minus 20 degrees C to plus 85 degrees C, and can be further trimmed with a calibration register. The RL78 integrates a low-power detect reset circuit like a POR, just drawing 0.08 microamps current typically. Data flash with background operation eliminates the need for external EEPROM, but also makes it convenient for the application to store user preferences, machine parameters, and log data. The RL78 data flash supports 1 million erase write cycles typical to match the life of external EEPROM. For high quality and safety, RL78 flash memory uses a well-proven flash cell structure at a 130 nanometer geometry for lowest power, ECC or error correction coding with 38 bits coding on every 32-bit flash word gives instruction data resilience to the flash memory contents for decades after flash memory is initially programmed. If flash memory is altered beyond the ability of ECC repair, the RL78 CRC, cyclic redundancy check, function block can find gross errors, and the software can act to shut down the MCU safely. And with a rich ecosystem, RL78 MCU designs are enabled by industry-standard development tools, such as the free GNU compiler, an Eclipse-based IDE developed by Renesas called E² Studio, as well as the Renesas proprietary CCRL compiler. Third-party support like the IAR software toolchain allows developers to reuse their knowledge base and software libraries from previously used MCU platforms. Extensive online resources help facilitate the design with online training resources, app notes, and reference software modules.